Hello and welcome. Today we're going to be talking about double displacement reactions. Okay, and once again, this you should have looked at last year, but once again, we're going to go more in depth with it this year, and we're going to look at some special cases as well. Okay, so let's start off and let's take a look right here. Okay, the bottom slide. Okay, and this bottom slide that we have kind of gives us our general form for a double displacement reaction. So we have two things over here and they're switching with two things over there. Okay, and once again, like I said, this is the general form. So let's go ahead and let's actually try an example so we can kind of get a better idea of what a double displacement reaction looks like. So what we're going to have for our first example is we will have sodium sulfate and let's say we're mixing it with silver nitrate. Okay, so we have sodium sulfate and we have silver nitrate, and we're going to make two products. Okay, so we're going to figure out what that is. So our first step is to come up with our equation here. So we have sodium sulfate, and the first thing we need to make sure we know how to do is come up with our formula. So sodium is Na, and it makes a 1+ charge. Sulfate, on the other hand, is SO4, and it creates a 2- charge. So once we do our crisscross here, we'd have Na2SO4. So that's right there as sodium sulfate. Next, we'll have silver nitrate. So silver is Ag. And if I'm not mistaken, once again, if you look at your periodic table, it makes a 1+ charge. And nitrate, on the other hand, is NO3. And it's 1- there. So we would have AgNO3. Okay, so those are our two reactants here. Now, what we're going to try to figure out is what are our products. Now, in order to do that, you need to kind of remember your single displacement reaction. And what's going to be happening is the same type will be switching. So if you take a look here, we have our positive charges, okay? And once again, another positive charge there. We also have our negative charges. So what's going to happen is two of these are going to switch. So the easiest way for me to kind of show you what's going to happen is that our two positive charges are going to be switching spots. And that's going to give us a double displacement. So silver, instead of mixing with nitrate, silver is now going to mix with our sulfate. So I'm going to go ahead and I'm going to put Ag, so my silver, which is 1+, and it's going to be switching with my sulfate, which is 2-. So once again, with our crisscross, we would get Ag2SO4. On the opposite hand, now sodium is going to be mixing with our nitrate. So we have sodium, which is still a 1+, and our nitrate, which is still a 1-. So we would get sodium nitrate. And this here is our process of doing a double displacement reaction. So when doing a type of when you're doing this type of reaction, you want to make sure that you can figure out which ones are your positives, which ones are your negatives, and then all you're doing is you're taking two of the same type and you're switching. So the easiest for me is just taking the two positive charges and switching their spots. Okay, now a couple things that you need to remember is that we always need to include our states. Okay, as of right now, we don't know how to come up with that, but we will be seeing that in this video very shortly. But also, you also need to remember to balance your equations as well. Okay, so if we're going to go through this question here, so I see I have 2 sodiums here. I only have 1 sodium there, so I'm going to put a 2 to balance out those sodiums. That's going to give me 2 nitrates, so I need 2 nitrates here. So now my nitrates are also balanced, but now I have 2 silvers, but I also have 2 silvers there. So everything here is balanced. And once again, this is just a general form of our double displacement reactions. Okay, so hopefully that made sense. We're going to go back to our lesson here. And once again, that is what this here is. So before we get into more specifics, we need to go through a little bit of some definitions here. Now, typically when we're doing a double displacement reactions, we're mixing 2 liquids together most times. Okay, there obviously are exceptions to this, but typically when we're mixing 2 liquids together, that's how we make a solution. And that's what we call homogeneous mixture. So there's a couple definitions that we need to go through to better help us out. So these 3 first definitions should make sense to you as you've been seeing this for the past couple years. So if I'm mixing salt with water, the salt is the substance that is being dissolved. That is what we call a solute. The water is the solvent. That's the substance that we're dissolving that salt into. So when we mix our solute and our solvent together, we make a solution. And once again, a solution is a homogeneous mixture. A homogeneous mixture means that you only see one color, but more importantly, one phase. And that's the proper terminology. Okay, so if you're mixing like Gatorade powder and water, let's say it's like blue Gatorade powder, you mix those 2 up, you would have a solution that is just pure blue. And that solution is a homogeneous mixture because you only see one part to it. A heterogeneous mixture on the opposite side is if you were to mix like oil and vinegar together. You would see both of those parts there. Okay, now I'm going to just skip over one portion. I'm going to go to our precipitate. Okay, now once again, if you were to mix 2 solutions together, if you were to form a solid, if a solid were to be formed, that's what we call a precipitate. Okay, so when we're mixing 2 things and a solid is formed, that solid is what we call a precipitate. Now, lastly, something that may be new to you is something called solubility. Okay, now solubility is how much you can dissolve at any given temperature. But more importantly is something that could have high solubility versus something that could have low solubility. So I'm going to give you an example of both to help you out. Something that would be high solubility would be something like salt. And if you were to put salt in water, it dissolves very fast, very quickly. And that's what we call something to have a high solubility. If you can dissolve something very fast, that substance would say, or what we would say is that it has a high solubility. If you were to dissolve or try to put in some rocks, for example, in water, okay? Well, if you try to stir those rocks around that water, well, most likely they're not going to dissolve right away. And reason why is because those rocks would have a low solubility. Okay, so there are different examples, but that kind of gives you the idea between something that is high solubility or something that is low solubility. Okay. All right. Now, before we get into some examples of our reactions here, what we need to figure out is, well, once again, if we go back to this example here, we're going to try and figure out what are these states. Okay. So in order to do this, what we need is we need this here. Okay. And this is our polyatomic ion sheet. And if you flip, this is the front side here. If you flip to the back side, you'll see this chart over here. Okay. Now, quickly looking through it, it might not make too much sense to you, but we're going to go through it and we're going to figure out what we have. Okay. So in order to do this, we're going to try one question here. We're going to try this first one. Okay, so we have potassium chloride, KCl. Okay, now you'll see another chart here. Okay, this chart and this chart are the same chart, just shown in a different way. Now, this is the chart that you would see in your textbook. This is the chart that we are going to be using in grade 11 and in grade 12. So this is the one that I want you guys to get familiar with, because this is the one that you'll get on tests, exams, assignments, stuff like that. Okay, so what we're going to do, we're going to try the first example. We'll try KCl. Okay, so potassium chloride. So I'm just going to work a little bit lower here. Actually, I'll get a new sheet. Okay, so the first one we're going to try potassium chloride, so KCl. Okay, now the first thing that we're going to do is we are going to figure out which one is our cation, which one is our anion. Now, if you're not familiar with those terms or you can't remember, your cation is your positive charged ion and your anion is your negatively charged ion. So if I have KCl, well, potassium is 1 plus, chlorine is 1 negative. So this is what we call our cation, because it has a positive charge, and this one is our anion because it has a negative charge. Okay, so that's what you need in order to figure out if you have, or what type of state this is in. So now that we know our cation and anion, we're going to go over here. So what we're going to do is we are going to look, okay, over here it says anion and cation, both of them. So we're going to look at our anion first. So our anion was chlorine. So what we're going to do is we're going to look down this chart and we're going to find chlorine. And I see chlorine over here. Okay, so there's our anion. Now what we're going to do is we're going to try and figure out where is potassium in our cation. So if I look at the top here, I have silver, lead, mercury, copper, titanium. So it's obviously not any of these. So our potassium would be in all others. So what we're going to do is we're going to scroll across here and we're going to find it to be soluble. Now, soluble means that this is able to dissolve in water. Because this is able to dissolve in water, we call something that is soluble aqueous. Okay, so if I have my KCl here, KCl or potassium chloride would be aqueous at room temperature. So now we can figure out what we have. Now, if we go back here, let's say we had, for example, let's say we had silver chloride. Okay, so I'm just writing here. Let's say we had silver chloride, for example. Okay, so once again, same thing. My anion is chlorine because it's my negatively charged ion. So I'm going to go here. I'm going to find chlorine, just like last time. But this time, I have silver. So if I scroll across here, I have low solubility. Low solubility means that it's not going to dissolve in water. Because it's not going to dissolve in water, we say that this here is a solid. And that's how we can figure out what our states are. So if we had these original questions that we were looking at before, once again, all we need to do is we need to find the anion, which is sulfate, and the cation, which is sodium. And same thing with all of these, and we can figure out if we have solids or aqueuses. Okay, so if I go back to my lesson, okay, we'll try the next one together. Okay, so I have silver chloride. Oh, that's the next one right there. Okay, so we already know the answer there is solid. Okay, let's try it. We'll do the third one then together. Calcium carbonate. So we have CaCO3. Okay, so I'm just rewriting it over there so I could have both together. So I have my calcium carbonate. So carbonate is my anion, which is my negatively charged. So as I look over here, I see carbonate down there. Okay, so as I look across, okay, so I'm looking for calcium. Now, calcium is an alkaline earth metal. Now, if you take a look here, it says all your alkali ions or alkali ions, hydrogens, and ammonium are all soluble. Now, a lot of people get confused with this. Your alkali ions are your first is your first group, and that's these ones here. These are your alkali ions. So if we had, for example, instead of calcium carbonate, let's say we had, I don't know, lithium carbonate. If we had lithium carbonate here, we would be looking at the alkali ions because lithium is an alkali metal. However, calcium is not an alkali metal because once again, these are your alkalis, these are your alkaline earth metals. So calcium is part of this group here. So because it's part of this group here, well, it's not any one of these. So we need to look at all others. So calcium carbonate has a low solubility, so we would say that this here is a solid. If we had lithium carbonate, well, because lithium is an alkali metals, this one would have been aqueous if we were doing this question here. Okay? So what I want you to do, okay, is I want you to try this last one. We have calcium hydroxide. Okay? Try this one by yourself and see if you can get if it's a solid or an aqueous. Okay? So take a second, pause the video, and attempt it, and then we'll come back and we'll see if you got it right. Okay, so take a second right now and try it out. Okay, so hopefully you did try this out. Okay, sorry, I'm just trying to find my sheet here. Okay, so we're looking for calcium hydroxide, which is this here. Okay, so I have my sheet, and let's take a look at what we got. So the first thing I'm looking for is hydroxide, because that's my anion, and hydroxide is right there. So as you'll notice, once again, there's alkali ions. So calcium is in the second group, so it doesn't follow here. And as I look across, calcium is not any of these, so it has to be all others. So calcium hydroxide has a low solubility, so that means this here would have been solid. Okay, and that is how we're able to tell what type of, what state, we have for our mixture or our compounds here.